Pleasure to introduce Luke Sneeringer, who will be talking to us about posting to the Python package index. This talk will be 30 minutes, including 5 minutes at the end for Q&A. Luke Sneeringer.
Thank you. To be entirely honest, this probably will not take a full 25 minutes. It's an incredibly simple topic. The amusing part of this is I submitted 4 talks to be done in PyCon. 2 were accepted. I thought this was the weakest one. I was very surprised when it was voted in. But anyway, the goal of this talk, well, actually, let me go in the order I had originally planned, because things will go a little bit better that way. So a little bit about me. I'm the sole software developer at a software startup. One of the things that I've had to do is figure out how to post things to PyPI. There's been a couple times when I've written something and thought, someone else could use this, and then sat down to do this. And it's not a very difficult process, but it's just esoteric enough that I thought that probably I am not the only person to have this problem. Probably there's some sort of value in offering an explanation of this. Really, it's very, very, very easy. But it could be a little bit more obvious. So this is a walkthrough. If posting reusable code to PyPI is something that you are interested in doing, then you should leave here today knowing pretty much exactly how to do that. And it's basically writing down 4 or 5 steps. But because this is a 25-minute talk, I'm going to do it in a very long and drawn-out explanation. The purpose of this talk is to encourage you to package and post more of your code. One of the great things about Python is that the packaging system is good, and because the namespacing and other aspects of Python are so excellent, we have a very, very, very good repository of reusable code, much more than you can find in many other places. And so when you go and do a project in Python, you can do a lot less work. You can be a lot lazier. And so this is a talk on how to pay it forward. And I'm going to do that by just giving a very big, brief overview of how to make a package. What is PyPI? PyPI is a repository of at least ostensibly reusable code. Most of it's pretty good, written by thousands of different people worldwide. It's a completely open system. Anybody can make a package, run a few commands, and post to it. More to the point, it's a great way to write less code yourself, because it was mentioned this morning that one of the great virtues of being a programmer is to be lazy. A quick history. Once upon a time, it was called the Cheese Shop, which I believe is a Monty Python reference. Some people still call it that. So if you hear someone talk about the Cheese Shop, that's what they're talking about. It was changed because the name was not incredibly descriptive. I remember Steve Holden up on stage a couple years ago saying that there were people coming to him saying, well, it's great that you have this thing called the Cheese Shop, but where do I go to get a Python package? So, so the name was altered. If you ever use pip or easy install, then you're almost certainly using PyPI. PyPI is the repository that powers those tools. So basically, whenever you pip install something, that means that someone else did the process that I'm going to cover today for if you want to post some of your own code. The next thing I want to go over is that this is really simple. It's not hard. It's a little bit obscure, but it's not hard. Which means I'm probably going to be sending you to break a little bit early. And somebody will be happy about that. Python packages are informed by a file called setup.py. You've almost certainly seen it in packages that you've downloaded if you've manually built something from source. I don't know if you've ever looked at a setup.py file, but it's an incredibly simple construction. Packaging code really comes down to this file. It gives information about other things in the package, and at least in the simplest case, you can make an entire package with just this thing. It contains all the information for posting and indexing on the index. You can provide lots of information. You can provide less information. Usually more is better. And it also contains all the information needed to install your package on disk. In terms of directory structure, usually setup.py goes above your code. So something like this. So if your code is in I'm assuming that you in the back can read that. If not, there's plenty of space. If your code is in the package name folder, you're probably going to have a README and a setup.py just above it. And we'll talk about that in a minute. And of course, the import path here would start with package name. Really, the setup.py file only comes down to two pieces: an import statement and a function call. The import statement is to import the function call that you're going to call, and then you call it. And that's it. No, really. This, of course, we haven't gone into what's in that setup thing below that, but that's basically complete. The import, just memorize, or if you're like me, you don't actually memorize it, you just go to the previous setup.py file that you wrote for a project 6 months ago and copy the first line, but it's .thisutils.core imports from thisutils.core import setup. The setup function itself, on the other hand, takes lots and lots and lots and lots of options. They're all keyword arguments, so it's pretty easy to do, and you can do them in any order and make your file look nice. And for the remainder of our time, we're going to be talking about this setup function. There's some stuff that you have to have. It will, fail out if you don't. You need a name and an author. That's probably not very surprising. The name doesn't have to match the actual package name import, but it is how your thing will be indexed. The author, well, I'm hoping you know who that is. Needs a version. Not particularly surprisingly, PyPI versions things, it expects a version to be present. It doesn't just use timestamps for relatively obvious reasons. And then you'll need at least one of packages or scripts. This is the reference to the code that you're actually including. Talking really, really quickly about the version question. The version is how PyPI determines what of your code is the most recent. When you've been maintaining a project for a month, a year, however long, you're going to have lots and lots and lots of different versions up, and this is how it knows what's current. It doesn't do that by just date. And the obvious reason is because you often maintain multiple versions of things simultaneously. An obvious example is Python 2 and Python 3. Python 2.7 came out after Python 3.0 and after Python 3.1. But nonetheless, it's probably considered an older version, even though lots of people use it. Versions are dot separated, exactly how you would expect. The format is major.minor, possibly .patch and .sub. There's a special comparison rules. The stuff between the dots is compared separately from left to right. If they're equal, you go on to the next spot. If they're greater than or less than, you return that answer. So 3.1 is greater than 2.7 because 3 is greater than 2. 3.1.2 is greater than 3.1 because the .2 is present. 3.10 is greater than 3.9 because 10 is greater than 9. Even though 3.1 is as a decimal less than 3.9. There are some suffixes that it understands: A for alpha, B for beta, -PR for pre-release. I'm pretty sure it also understands -RC, but this is what was documented. Now I'm going to talk real quick about the packages keyword. Packages tells setup.py install or pip, which all pip actually does is do a build and then do an install, what packages it's supposed to install. They're relative from the location of setup.py. So if you remember the screenshot earlier where we had setup.py and we had a package name folder, your packages list would be just one thing with the string package name in it. It's technically optional, but you almost always need this. The case where it's optional is if you have scripts and don't have any packages. So you remember this. I just showed it earlier. Setup.py, and then a package name, which is a folder that's peered to it with your code in that folder. This is your packages declaration. Packages equals, and then a list with the string package name. It is a list. You can have more than one. The scripts option is an alternative to packages, although you often have both. Scripts is the location of scripts that should be installed to the shell path. These are things that are intended to be executed from the shell. Django admin.py, for those of you who use Django, is a very obvious example. That's installed on your system path, And you can call Python Django admin.py from anywhere. I think you can also call it with // if you're on Linux. And yeah, that's my common example. Scripts tend to be chmod executable for Linux environments. It just makes people's lives easier if they are. You can omit the .py extension on Linux by using your frontline hashbang, such as hashbang user benimp space Python. But remember that you're posting packages, which means that not everyone who retrieves them is going to be using Linux. You cannot make that assumption. Or if you do, you need to be clear about it. Both of these things are technically optional. Functionally, you pretty much always need one of them. It's not really meaningful to have a package posted with no code. And so this is a technically complete but sparse setup function. It has a name, it has an author, it has a version, and it has a packages declaration. It could have also had scripts if there had been one. There are lots of other things that the setup function does. Generally, the more you specify, the better, the more useful your posting is for someone who's looking for it. A few obvious examples that don't really need a whole lot of discussion are description, which is just a longer textual description. The author email address, you don't have to specify it, it does help. The URL, if your project is hosted on GitHub, if your project is hosted on GitHub, even that can be very useful. And this URL here, docs.python.org/disutil/script.html, has the full list. I do want to talk about one of them. Actually, I'm going to talk about a couple of them. First, I'm going to talk about is classifiers. Classifiers is this actually kind of strange system that PyPI has for addressing how your package should be indexed. It's basically a whole bunch of buckets that things can go in. So you can say that your package is considered to be in beta or is considered to be stable. You can put what operating systems are supported. So if your package only runs on Linux or only runs on Windows, this is the place where you can put that. And basically, these are kind of checkboxes that it does. It's not smart enough to know that any of them are mutually exclusive. So if you say that your thing is beta and stable, it will take it, at least as far as I know. And it's stated as a list of these special strings with lots of colons. And I'm not going to show it except to say that if you really want to see it, there's a list on pypi.python.org/pypi, !action equals list classifiers. Wonderful URL there. And you can find that pretty easily just by looking up classifiers from the PyPI main site. Once you've made your setup.py file, the next step is to actually distribute it, the act of registering it on the index and uploading it. Obviously, making a setup.py file does no one any good if you don't do anything with it. There's two steps. The first step is setup.py space register. This basically, the purpose of this is to tell PyPI that your package exists. It will not do any uploading. It will, in fact, do not much of anything except for it will take your setup.py information, the author, the name, and post all of that and add a database entry on PyPI. What it will not do is upload any code. So if you only do this step, what you're going to find is that if you search for your package on PyPI, you will have a package, and it will have no downloadable files. There will actually be no way for anyone to download your package, and pip will be very confused. But it will technically register that your package exists. The second step is actually uploading. And the know-nothing way to do this is Python space setup.py space sdist space upload. This has to be one command. sdist stands for source distribution. It basically tarballs your source code, whatever you've pointed to, and then uploads it. It has to be one command. If you only do setup.py sdist, you will be given a tarball on your computer, and that is all. And if you do Python setup.py upload, it will say, I don't have anything to upload, I'm not interested, go away. It has to be one command. There are a few other batteries that are included in here. In particular, you can make binary distributions as well. You can make an RPM for those Red Hat people. You can make a setup.exe file for Windows. Most, especially smaller packages, don't tend to do this. It's pretty easy to build something from source, especially now that we have pip to do all the hard work for us. So this is something that you generally do if your package has a lot of complicated dependencies or something else is involved whereby an RPM is more useful. If you've tried to install, say, PIL, the Python imaging library, or one of the XML parsers, LXML, that depend on C libraries being installed, then suddenly these other things look a lot more attractive. But generally for pure Python stuff that only has Python-based dependencies, sdist upload is fine. Again, remember to put upload after them in the same command, or all you're going to do is get a nice binary distribution on your disk and nothing else. We're basically done at this point, but I want to make a couple of comments that have some sort of ancillary relationship, and then, again, we'll be dismissing. The first is reusable code. Since we've gone over how to post reusable code, this is a short sermon on writing reusable code. Always remember that people using your software may not have the exact same use cases that you do. I don't know if anyone went to Raymond Hettinger's excellent talk yesterday on the art of subclassing. But if you did, he went over a whole lot of stuff about subclassing and went over this in great detail. The idea that the way that you're using your class may not be the way that someone else is using your class, and that the instances have control. So just a quick checklist of things to remember. Use options. Make it so that behavior can be customized. Support subclassing. Again, I'll reference that talk. If you didn't go to it, the video will be up at some point, and it's much better than this one. Consider writing methods that accept a subclass as an optional argument. If you went to my talk on metaclassing, I touched on this very briefly, that you can actually write functions that take classes, and that can sometimes, that is a great reusable toolbox mechanism for allowing someone else to patch in their own functionality. And the bottom line, think about general needs and not just your specific needs. And don't forget about documentation, or the Django pony will hunt you down. One more quick rabbit trail before we go. A friend of mine was going over my slides and said, I would love for you to have a slide on this thing, even though it's not completely related. And I said, well, I'm going to be going under time, so sure. So it's unrelated, but it's something that you'll want to know. And it's being featured because it's new and exciting. There's a problem with PyPI, if anyone has ever used it. And the problem is, it goes down a lot. Really, quite a lot. It's not something where it's down 50% of the time, but I will say that my ops guy who runs 80 servers for our company, he's constantly spinning up and deploying our code on new servers, and there's nothing that sets him off more than when he tries to spin up a new server and PyPI is down. And he goes to run his chef script that retrieves HTTP-lib and dispatch and all these other things, and it's like, no, I'm not going to give you your code. Sorry, go away. In fact, that pretty much sends him into Hulk smash mode. There is someone working on this problem. Actually, there are several people working on this problem, but I'm only going to be identifying one. And that's crate.io. Crate.io is a site that is a cache/mirror of PyPI. It's compatible with pip. You can configure pip to use it. And really, this is just a shameless plug. And now that shameless plug is complete. And with that being said, we are done. If you're good to go, feel free to head to break. This was not particularly complicated. If you have a question for me, feel free to stick around. Thanks.
Ready? One thing to note is that setup.py is going away in Python 3.3. It's going to be changed to setup.config. And so it won't be a runnable. There's a lot of people putting other stuff in the setup.py function that shouldn't be in there, so they're changing it to that. And then also distutils2 instead of distutils will be natively included in 3.3.
So to repeat what to repeat what he said for the recording and for posterity in general, basically what he said is that a lot of this talk is actually going out of date. Python 3.3 is deprecating. Distutils 1, there's going to be a brand new spanking one, and setup.py will cease to be a Python file and become a configuration file. And yes, thank you.
Yeah.
I was wondering if there's any feedback mechanism so that if you submit something or put something up there that people will give you complaints or criticism or whatever.
You have unknowingly stepped on, the landmine. To repeat the question for the tape, basically what he asked is there a feedback mechanism on PyPI? Is there something where if you submit code that sucks, people can tell you that your code sucks? Or if you submit code that's awesome, people can tell you that your code is awesome? The answer to that question is no. There actually was at one point a starring mechanism where you could rate on a scale of 1 to 5 stars various different packages. That mechanism has gone away as of 2 years ago-ish, and the reason is drastic underuse and the fact that it wasn't really very valuable. There's not a whole lot of value in say giving Django 5 stars, or giving someone else's package 1 star. And it was very underused. To put it in perspective, the current version of Django, which at the time of the system being removed had been around for, the current version was 8 months old, and the project is probably the most popular Python project, and it's years and years and years old, had 14 ratings. So it was considered to be not useful. A feedback system, it's kind of being duplicated. A lot of the code is, you can just go to their GitHub page and do the same thing. So the general idea is that that's better handled by bug trackers. PyPI duplicating it, to the extent it tried, it wasn't useful. They talked about expanding it instead of eliminating it, and the general feeling was it probably wouldn't be useful, so they eliminated it.
So I've somehow managed to remain blissfully ignorant of all things packaging over the last few years, and I was diving into an unmaintained open source project and found the egginfo directory that gets generated was actually checked into source control. Is there ever a reason to check that in, or is it always perfectly fine to let the installers generate that stuff?
You're a little bit above my pay grade. I am 90-ish, 5-ish% sure that probably that should be in getignore or not checked into source control, and that that's a mistake. I wouldn't swear to it. But no reasons are coming to mind like, oh yeah, here's the example where you would do this. Nothing's coming to mind. So I think the answer is that you always ignore it.
So I don't know a lot about PyPI, but I know a lot about CPAN, which is the Perl version of the same thing. Mm-hmm. And in CPAN, you can upload bundles, which can include many modules, which are like, say, the module corresponds to a package in Python. And each module has its own version. So it would be like each... I guess that's sufficient explanation. So my question is, say you're uploading some Python package that contains other Python packages, but only a few of them are getting a version bump. Is there a way to record that in your setup information?
So the question, again, repeating for the tape and the like, is what if you're posting something more complicated where you have 3 packages and you want to upload them at the same time? I actually have a clarifying question so that I'm understanding. Are these all packages that you are maintaining that are interdependent, or are some of them other people's packages?
Say they're all yours.
Okay. I guess actually I don't know why I asked that clarifier, because the answer is the same either way. There is a dependencies notion where you could say package A depends on package B, and package B has to be greater than 3.0. And I'm uploading package A version 1.0 that depends on package B 3.0. And then you upload package B, wherever you are. That's, I think, the way that that's generally done, is through dependencies. Now, you could absolutely have more than one package or more than one Python module in your package. If they really are a single self-contained unit, packages is specified as a list.
Yeah, I guess the place where it gets a little weird is, say you have a package that has many modules in it, but someone might be using those modules individually. You want to be sure that they can get the specific version of that specific module that they want. So do you is there a way to put a version on each module that you're uploading within your package?
If you send them up separately, yes. And then you go into specifying that this package has a dependency on this other package. If you do them at the same time, no.
Okay, thanks.
Sure.
Hi. For code that does have C dependencies, is the process related to this, or is it a totally different animal?
You can post things with C dependencies on PyPI. I have never done it, and I've never researched it. So the short answer to this question is I have no idea.
OK. Neither did I.
I'd like to point out that there actually is already a failover approach to the package index. So if the master server fails, you already have like 6 or 8 mirrors that people can use. So there already is redundancy.
Yeah. So the statement is, I put a plug in here for something that a friend asked me to point out about Crate. And the statement for the tape is, there really are quite a few of these. It's not the first one.
Somewhat tangential, but pip versus easy install. Is there a difference? Why does pip seem to be preferred? Which one should we use?
So the question for the tape is the difference between pip versus easy install. I am not the person to be pontificating on this, but going into it briefly, pip is newer, is probably the big thing. There's a few differences. Pip's ability to handle uninstalling and upgrading is a little bit better. Uninstalling in particular, you just can't do with easy install. If you easy install something and you want to get rid of it, you have to go into user lib Python 2.7 or library/python/2.7/site packages or disk packages. You have to find it in the directory tree, which means you have to learn where it is and chunk it. Pip can handle uninstalling is one of the reasons. Another difference is it's a little bit better at upgrading. In easy install, you can actually have a situation where you have to remove your package to easy install it again to get an upgrade, and pip has a mechanism for that. Probably the most compelling reason, though, why pip is preferred is because pip plays nice with virtualenv. Virtualenv, they're actually written by the same guy. Multiple people have contributed, but the guy behind pip and the guy behind virtualenv, Ian Bicking, is the same guy. And virtualenv is a tool that lets you basically set up sandboxed Python environments for development. So if you're developing one piece of code that needs version 1.3 of something and another piece of code for a different job that needs version 1.5 of the same package, you can manage that by bouncing between your virtualenvs and kind of keeping everything siphoned off. And it also is virtualenv is well loved, again, because it lets you kind of isolate your development and your production. So if you're a type of guy who develops lots of different stuff, you don't accidentally use a package and forget that that's just always installed on your drive and forget that you used it and then you send it up to production and everything breaks or something like that. So pip plays very nice with virtualenv. Virtualenv sets things up kind of within your home directory and sets up actually a different pip. You can even use virtualenv to have different versions of Python running simultaneously.
One other short question. Where do the Trove classifiers come from, and is anything actually using them, or is it kind of metadata for the sake of metadata?
The external classifiers are, I'm not completely sure the answer to that question either. I think that PyPI itself uses them, so you can say, like, I want to only look at stuff that's stable, or I want to only look at stuff that runs on Linux. So I think they're search criteria. Beyond that, I think they're crossed. Oh, okay. So she made a great point. I want to make sure I repeat it for the tape. One of the things that handles as well is it will tell you what version of Python you need. So if a package only runs on Python version 2.6 and up, or only runs on Python 3, that gets stated there. That's a really big deal right now, especially because the Python 2 versus Python 3 distinction, we're still running in parallel worlds, and we're going to be running in parallel worlds for another couple of years. So until Python 3 has completely subsumed Python 2, that distinction especially is going to be very, very important.
Any more questions? Thank you.
Thank you all.